Welcome to Get Glimpse channel. Running Meta's Llama 4 locally on your own machine is an exciting way to get a powerful open source AI model with a focus on privacy and control. Unlike a cloud-based service, all processing happens on your hardware, meaning your data never leaves your computer. However, running a model of this size requires specific hardware and a solid understanding of the necessary software tools. So, here is a step-by-step guide on how to run Llama 4 locally along with the essential considerations. The first step is to check your system requirements. Llama 4 is a large and computationally intensive model. While it's possible to run it on a CPU, you'll need a powerful GPU to get a responsive experience. So we have this hardware requirement which is CPU only, which is low. A multi-core CPU with at least 16 GB of system RAM. We have GPU, which I would recommend, and it's also recommended an NVIDIA GPU with at least 8 GB of VRAM for a quantized model. We have operating system as well, Windows 10 or 11, Mac OS or Linux. We also have disk space. The model weights are large, often tens of gigabytes or more. Ensure you have ample free disk space. The second step is to choose your local runner. The easiest way to run Llama 4 locally is with a user-friendly tool that handles the complex setup for you. We have Llama, which is recommended. This is the most popular and user-friendly method. Llama is a streamlined tool that packages everything into a single application, making it simple to download and run models with just a single command. It also handles the tricky bits of GPU acceleration automatically. Now, this is how to use Llama. Download and install the Llama application in here for your operating system. Open your terminal or command prompt and run the command Llama pool llama 4. After the download is complete, you can start an interactive session by running Llama run llama 4. We have another one here which is llama.cpp. This is a more technical but powerful option. Llama.cpp is a high-performance C++ inference library designed to run Llama models efficiently, as you can see here in GitHub, on a variety of hardware. It's the best choice for developers who want more fine-grained control over the model's parameters and hardware utilization. Now, this is how to use llama.cpp. You will need to clone the llama.cpp repository here from GitHub, build the binaries, and then download the model weights, often in gguf format, from a platform like Hugging Face. Then you can run the model from the command line, specifying the model path and other parameters. Now the third step is download the model weights. This is a crucial step. You must agree to Meta's licensing terms before downloading the Llama 4 model weights. From Hugging Face, the Llama models are available on the Hugging Face hub. You'll need to have a Hugging Face account and be logged in to download the model files. We also have quantized models, strongly recommended from me. The full precision Llama 4 models are enormous, that is around 100 GB plus. Quantized versions are smaller, faster, and require significantly less VRAM and disk space with a minimal loss in quality. The fourth step is to run the model and start interacting. Once you have your local runner and the model weights, you can start an interactive session. For Llama, after pulling the models, just type Llama run llama 4 and you will be dropped into a conversation with the model. We also have llama.cpp here. Use a command like llama-cli-model path /to/llama for gguf-p. Like this. What is the capital of France? To get response. Now, let's get to the troubleshooting and optimization. We have GPU memory errors. If you get an out-of-memory error, try using a smaller, more heavily quantized model or a model variant specifically designed for low VRAM GPUs. We have slow performance as another error. If you are running the model on a CPU, this is expected. To get a faster experience, you'll need to use a GPU. Ensure you have the latest NVIDIA drivers and that your runner is configured to use CUDA for GPU acceleration. If you also have missing dependencies, if you are using the more manual llama.cpp approach, you may need to install specific Python libraries like torch and transformers to solve the missing dependencies error. By following these steps, you can harness the power of Meta's Llama 4 model on your own machine, gaining unparalleled control, privacy, and the freedom to experiment without relying on a cloud service. Thank you for watching. If this video was helpful, then please leave a like and subscribe to my channel for more videos like this.